Hi, I'm JLSPMA, and today I will be teaching you how to solve a 5x5 or bigger cube layer by layer. This is a very simple method to learn, but it's not the speed cubing method. It is not the best way to solve it quickly. This is just an alternative method. Yes. The objective of the layer by layer solve is you obviously solve the first layer without solving the rest of the layers, then progressively solving the rest of the layers until the last one. This method can be transferred to bigger, odd cubes. I will be making the tutorial next on the even layered cubes, which will be easier to solve, although require other methods in a way. So for simplicity, I will use the black face as the bottom face, and I will progressively solve layer by layer until I get to the yellow face. This is a V-cube, by the way. First part in solving your layer by layer the cube layer by layer is to force scramble it. Okay, now you will need to know how to solve the 5x5 the regular way. The first thing to solve is one of the centers. So we will solve the black center, or the white center if you have the black V-cube, or the black 5x5. So I will quickly solve the first bar, then the second bar. This requires previously known methods for the 5x5. Okay, and I solved the first center. Now, to solve the first layer, you will need to pair up the edges of the corresponding layer. So you'll need to pair up the blue and black edge, the blue and red edge, the blue and green edge, and the blue and orange edge. So I have here two already paired up, and I need to pair it up with the other black and red. So we'll look for it. Here it is. So quickly pair it up, and you do not need to worry about putting it back here and switching the centers again, because the cube is scrambled. So you pair up the first edge. The second edge I already have here partly solved. This does not always happen, just out of luck actually. So I'll pair this up and put it here. The next one, I'll pair up the black and blue edge. You look for another piece to go with the black and blue edge, which look around the cube. Here it is. You pair it up right here. Turn this cube so when you turn this part of the cube, so when you're turning the other faces, it doesn't interfere. So you pair it up like this. Then you put it back up here. And now here's the other part of the edge. So you quickly arrange it so you can easily pair it up, then put it on top of the layer. Here it is. And the last edge is the black and green edge. And here's already one of the pieces solved in its correct position, I guess. And quickly have to solve the last edge. So here's one of the green and black pieces. I paired up with the other green and black piece, and the other green and black piece, and I put it up here. And I've solved the centers and the four edges. The center and the four edges. Now we'll go into the corners. Quickly insert the corners, as you may already know. So here's the first face completely solved. For the second face, you will use the beginner's method. for solving the second face. So, especially for the edges, you will need to use, as an example, use a 3x3. I will show you the 3x3. After you've inserted the corners, you have these edges. In the beginner's method, you have these edges that you need to insert. The algorithm for it is obviously this. And the other algorithm is the same but mirrored. And there's the algorithm for inserting edges without touching the rest of the face. So for that, you will need to incorporate it into the 5x5. So first you look for any edge here that you can use to pair up with the rest of the face. So I'll look here and see that, for example, I have one here already. You may not have one, but if you're lucky, you can have already one edge solved. For the second edge, you will need to use algorithms. Very short, simple triggers that can get the piece where it is. So, for example, for this, you will need the green, as in for this algorithm. You need to pair up this color with the rest of the colors, so you can do the algorithm. The same with this. You will need a piece here next to the rest of the colors here, the greens, and it has to be close to the edge, so you will not use the other green and red edge here and it matches here. You cannot use that edge because you won't get it. You will get it here. You need to use this edge here. So for any other case, example, this case, you would not use it because this blue is matching, but when you doing the algorithm, the corner doesn't meet up with the other edge. So for that, you need to do the algorithm with a piece next to the rest of the edge, and you do the exact same algorithm using only the outer faces. Here it is. The third edge is actually right here. Blue fits with the blue. It's close to the edge where you want to insert, and it's on the opposite side. This time we'll use the other algorithm, the mirror version. And for the last edge, you will use the same situation. You use it in the same way. Now, if you do not have an edge to insert from this face, and you do not have it here on this bottom middle face, you will have it obviously here on this face here. Now, for that, I have, as an example, I have the two edges here. This is one of them, and this is the other one to insert here. To figure out which one to insert, you will know that if this piece matches this piece in colors, and this matches this, it means that this is not the correct piece to insert here. If it doesn't match with this piece, for example, it doesn't match with this color, and this one doesn't match with this color, it means that you need to do an algorithm to insert this piece here, and that is the edge flipping algorithm. The edge flipping algorithm goes as follows. And it's here inserted. Now all the edges are in their correct places. You see the 4 edges here are in their correct places. Now, you need to insert the centers here. To insert the centers, you may use advanced algorithms for specific parts of the centers, but I will use the general algorithm for it. The general algorithm for it is